Hello everybody. In this video we'll be covering one of the sections from chapter 8 of our text entitled Quantities and Chemical Reactions. In this video we will be discussing limiting reagents. So I want to go back to our pancake analogy for a moment. So we know that in our recipe we have 1 cup of flour, 2 eggs, and half a teaspoon of baking powder to make 5 pancakes. So before we considered what happens if we had a limited number of eggs and more than enough flour and baking powder, but what happens if we're not sure which one is going to limit how many pancakes we can make? All right, so what if we had 3 cups of flour, 10 eggs, and 4 teaspoons of baking powder? How would we know how many pancakes we could make? Well, what we would need to do is figure out how many pancakes we could make with each reagent, assuming that we had more than enough of the others. Okay, so if I had 3 cups of flour and more than enough eggs and baking powder, I could make 15 pancakes. If I had 10 eggs, I could make 25 pancakes. If I had 4 teaspoons of baking powder, more than enough eggs or flour, I could make 40 pancakes. So with that information, we know that with each ingredient we could potentially make a different number of pancakes. But we also know that we need all of the ingredients. They all have to work together. So since we only have enough flour to make 15 pancakes, the flour is going to run out before the other ingredients. So no matter what, we can't make more than 15 pancakes. This is our limiting amount. This is our theoretical yield of pancakes that we can make. Because once we've made 15 pancakes, we're going to be out of flour. That makes flour our limiting reactant or limiting reagent. Okay, so we will never be able to make more than 15 pancakes, and when we're done, we would have consumed all of our flour. The flour limits the amount of pancakes we can make. In chemical reactions, we call this the limiting reagent. Some other texts may call it the limiting reactant. The maximum number of pancakes we can make depends on this ingredient. In chemical reactions, we call this our theoretical yield. It also determines the amounts of other ingredients that we will use. Okay, so it determines how many other ingredients are going to be consumed. It also determines how much of excess ingredients there will be. How much can we use? How much will be left over in the end? Let's try a problem here. So what is the limiting reagent and theoretical yield when 0.552 mole of aluminum react with 0.887 mole of chlorine gas? And we're given a chemical equation here. So we have 2 moles of aluminum metal plus 3 moles of chlorine gas is going to produce 2 moles of aluminum chloride. So our quantities we're given are the moles of aluminum and the moles of chlorine gas. And we're asked to find the moles of aluminum chloride that we're going to have. In order to solve this, our solution map is going to involve us doing 2 sets of calculations. First, we need to figure out how many moles of aluminum chloride we could make with the amount of aluminum we have. And then we're going to need to figure out how many moles of aluminum chloride we can produce with the amount of chlorine that we have. Of these 2 values, we'll pick the least amount, and that's going to be our limiting reactant, either aluminum or chlorine gas, and the amount that we make is going to be our theoretical yield. The relationships we're going to need are going to come from the chemical reaction that we have up here, the chemical equation. And they're going to come into play in these steps here, right, where we're using our stoichiometric conversion factors to figure out how many moles we can produce given the amount that we have. So first, if we look at the moles of aluminum, multiplying by our factor here, we see that we can produce 0.552 moles of aluminum chloride. Next, if we look at our moles of chlorine gas, applying our conversion factor here, we'll see that we can produce 0.585 moles of aluminum chloride. Now I do want to warn you guys when you guys are doing these that now we have a lot of different values, all that have units of moles. So it's very important that you label them and keep them straight. Which conversion factors we're using, what needs to be in the numerator and denominator, and making sure that you're paying attention to how many moles you're given in the problem here. Okay, because it can get very confusing when you have a lot of different values that all have the same unit. Now from here, what we need to do is make our decision. Which of these is our limiting reagent? And that's going to be our aluminum, because it produces fewer moles than chlorine gas would. Okay, so we're going to consume all of our aluminum metal, and we'll have some chlorine gas left over in the end of this. Okay. So that makes 0.552 moles of aluminum chloride, our theoretical yield, and it makes aluminum our limiting reactant. Let's try another problem here. How many moles of silicon nitride can be made from 1.2 moles of silicone and 1 mole of nitrogen gas in the reaction 3 silicone plus 2 moles of nitrogen gas to produce silicone nitride. So we're given the moles of both of our reactants, right? Silicone and nitrogen gas. And we're asked to find the moles of our product, silicone nitride, trisilicone tetranitride. So what we're going to do is we're going to be going from the moles of silicone to the moles of our product, and from the moles of nitrogen to the moles of our product. In order to do that, we're going to need the relationships from our equation up here, right? So we're seeing that we're going to need to consume 2 moles of nitrogen for every 1 mole of trisilicone tetranitride that we're going to produce. And we need to consume 3 moles of silicone for every 1 mole of product that we produce. We will make our conversion factors here. Again, making sure that we have the right units for what we want to cancel in the denominator and the units of what we want to have in the end, or moles of product, in the numerator. If we do it with if we apply our conversion factor with the silicone, we see we produce 0.400 moles of trisilicone tetranitride. And if we apply our conversion factor to the nitrogen gas, we see that we produce 0.5 moles of product. We make our decision based on which is the smaller yield of the two, which is going to be with our silicone over here. And we know that our theoretical yield is going to be the 0.4 moles, and our limiting reagent is going to be the silicone.